Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muhammad Najib, and I will be presenting my team for artificial intelligence algorithm presentation for CSC583. Our team consists for 3 members, which is me, Muhammad Muhammad Najib, Muhammad Mishal Adam Iman bin Hamzah, and Muhammad Hidayat bin Kasrat. For the introduction, our team is focused on using deep learning to classify four types of footwear, which is shoe, heels, sandal, and boots. By training the convolutional neural network, which is the abbreviation of CNN, on the last set of image, our team aim to teach the model to recognize the visual differences between each categories. This system has practical application in e-commerce, especially in commercialized marketing, such as creativity, fashion analysis, and a showcase. And it's a showcase of how AI can tackle a real-world image application challenge.
Objective 1. To develop a CNN model to classify footwear images into shoes, heels, sandals, and boots. Number 2. Support real-world applications like e-commerce, inventory management, and fashion recommendations. Input data. Footwear images were collected from Bing, Google Images, Unsplash, and Pexels to ensure variety in style and background. Each image was manually checked for quality and correct category placement. Images were converted to JPEG using Python and resized to 100 by 100 pixels RGB using MATLAB. These processing steps ensure consistency for effective CNN training. The data sets include 200 images per class, totaling 800 images across 4 categories.
So this is our first experiment. We have total of 10 experiments in this project. So in this experiment, we are using a filter set of 1632, optimizer equal to SGDM, learning rate equal to 1e minus 3, L2 equal 0, dropout equal to false, and augmented data equal to false. So let's run this experiment. This is our training progress. At the right side, you can see the training iteration, which is 216. We have 12 of inputs. Iteration per input is 18, and maximum iteration is 216. So for the validation, we have every 50 iteration. So let's wait for the result. So this is the result for our experiment. The validation accuracy is 49.50%. Next, in this experiment, we using a filter set of 1632, optimizer equal to SGDM, learning rate equal to 5e minus 4, L2 equal to 1e minus 4, and for the dropout we equal to true, and augmented data equal to true. So this is the result of validation accuracy. We only get 43%. Next, in this experiment, we are using a filter set of 16, 32, and 64. Our optimizer equal to SGDM. Our learning rate is 5e minus 4. Our L2 equal to 1e minus 4. our dropout equal to true and our augmented data equal true. So as you can see here, for the result, the validation accuracy is 48%. So in this experiment, we using a filter set of 60, 32 and 64. Our optimizer equal to STDM. Our learning rate is 5e minus 4, L2 equal to 1e minus 4. Our dropout equal to false and our augmented data equal to true. So let's run. For the result, we get a validation accuracy 47%. In this experiment, we using a filter set of 32, 64, optimizer equal to STDM, learning rate equal to 1e minus 3, L2 equal to 1e minus 4, dropout equal to true, and augmented data equal to true. So let's run. So for result in this training progress, we get validation accuracy 39.50%. Next, in this experiment, we using a filter set of 16, 32 and 64, optimizer equal to STDM, learning rate equal to 5e minus 4, L2 equal to 1e minus 4, dropout equal true and augmented data equal true. So let's run. The result of this training progress, we get a validation accuracy 42.50%. This experiment, we're using a filter set of 32, 64 and 128, optimizer equal to STDM, learning rate equal to 5e minus 4, L2 equal to 1e minus 4, dropout equal true and augmented data equal true. So let's run this experiment. So the result of this training progress, validation accuracy is 36.50%. This experiment, we're using a filter set of 8, 16, 32 and 64, optimizer equal to STDM, learning rate equal to 5e minus 4, L2 equal to 1e minus 4, dropout equal true and augmented data equal true. So let's run this experiment. As you can see here, this the training progress result, we get a validation accuracy of 51.50%. This experiment, we're using a filter set of 60, 32 and 64, optimizer equal to STDM, learning rate is 1e minus 4, L2 equal to 5e minus 4, dropout equal true and augmented data equal true. Let's run this experiment. Training progress, we get a result for validation accuracy which is 45%. For the last experiment, we're using a filter set of 60, 32 and 64, optimizer equal to STDM, linear rate equal to 1e minus 3, L2 equal to 1e minus 5, dropout equal true and augmented data equal true. So let's run this experiment. For this training progress, we get result for validation accuracy, which is 45.50%.
This is the first test where we want to check for the hill image accuracy. I will press the run button. We will use the experiment 8 since they have high validation accuracy. On this training progress, our validation result is 48.50%, and this is our prediction where the table show hills have a high probability and our model able to accurately detect the new image with the accuracy of 74.7%.
While on the second test, which is where we want to check for the sender image accuracy, I will run for the test now. On this training progress, our validation result is 42%, and this is our prediction table where the table shows have a high probability and our model have able to accurately detect the new image with the accuracy of 80.4%.
In the third test, which is where we want to check for the shoe image accuracy, so I will run the test now. On this training progress, our validation result is 47.50%, and this is our prediction table where the table shows the shoes have a high probability and our model able to accurately detect the new image with the accuracy of 97.060%. For the last test, which is we want to check the slipper image accuracy, in our prediction table where the table show the slipper have a high probability and our model able to accurately detect the new image with the accuracy of 67.70%. This diagram shows the architecture of a convolutional neural network CNN used to classify footwear image into 4 categories: heels, sandal, shoe, and slipper. The process begins with an input image that passes through several conv 2D layers with batch normalization and reload activation, allowing the model to extract important features like edge and texture. Pooling layers reduce the spatial size and help prevent overfitting. A dropout layer is added for regularization, followed by a flattened layer that converts the feature map into a 1D vector. This vector then enter multiple fully connected layer for classification, and finally, a softmax layer generates a probability distribution for each class, and the highest value determine the predicted output, in this case identifying the image as a pair of heels with 88% confidence.